Alright guys, let's start example 5, which again, it's basically a very similar problem to the previous one. So, if you think you got number 4, and you want to try example 5 on your own, go ahead and copy the problem down, pause the video, and fast forward to the end when you're done, and see if you did it correct. But, let's dive in. Okay, so, remember our exponential form is y equals a times c raised to the x. So, our a value is still not 1. Remember, a is the number that does not have the exponent on it, which is the 3. So it's not 1, so remember we just have to do one extra step on these problems. So first step, growth or decay. You figure out what the c value is, and that's all you have to do. So c is the number associated with my exponent, which is 1/4. So my c value is 1/4, which is in between 0 and 1. So this is going to be a decay. So I already know that my graph from left to right should decrease. Already know. We can already predict the future. How awesome. Okay, so our 3 points. Remember, this is the part where we have to do an extra step. So my 0, 1, I'm just going to rewrite as 0, 1. We will be doing something with that in a moment, so wait for it. At 1, we choose c, so c is the base, which my base is 1/4. Okay, and then at -1, we find 1 over c, which remember, all you do is find the reciprocal of c. So my c value is 1/4, so the reciprocal of 1/4 is 4 over 1. Okay, which 4 over 1 is the same as 4. So I'm just going to rewrite this as 4. Alright, so this is the extra step we have to do. So remember, you leave those x's alone. Do not touch them. So my x's are 0, 1, and -1. Now I'm going to write my y values, but we're going to do something with them in just a moment. So I have 1, I have 1/4, and I have 4. So remember, when you have an a value that is not 1, you're going to take your previous y values and multiply them by the a, which in this case our a value is a 3. So I'm going to take all my previous y values and multiply them by 3. Now this one I'm going to write as 3 over 1 since we have a fraction here. So it's easier to multiply fractions when things are written as a fraction. Okay, and I'm going to write my 3 points down here so I don't intrude on our graph space. So my first point, the x value is 0, and my y value is 0 times, my y value 1 times a 3 will give me a 3. So my first point is at 0, 3. So 0 up, 1, 2, 3. Okay, my next point, my x value is a 1, and remember when we have fractions, the way that you multiply fractions is to go straight on across. So 1 times 3 gives me a 3, and 4 times 1 gives me a 4. So my next point is at 1 3/4, which I'm just going to approximate. 3/4 is almost 1, but not quite 1, so I'm just going to put it right here. And then my final point, my x value is a -1. And my y value, 4 times 3 gives me 12. So this point's going to be way up in there. So we have -1 up 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So about right there. Alright, now before we connect our dots, we have to write in our asymptote equation, which remember on these problems, it's always the the x-axis, which is at y equals 0. Always the same thing. So I'm going to go ahead and draw in our asymptote line so we're not tempted to cross it. Bad things happen to people that cross the asymptote line, so you better watch yourself. Alright, I'm going to connect my points now. So these 3 is going to shoot up really fast. This graph's increasing really quickly. Sorry guys, slightly missed my point. Alright, and then this we're going to get really close to 0 but never touch. So it looks something like this. And this graph's name is going to be Andy the exponential. Awesome. Alright guys, and domain and range, like before, same thing every time in these problems. So domain is the x values on the graph. So we ask ourselves, how far left does the graph go? Okay, which this graph will get wider. I know it doesn't look like it, but I promise it will. Okay, so it goes from negative infinity on the x. Then we ask ourselves, how far right does it go? Which is shooting off in the positive infinity direction. So that's interval notation. And then remember inequality notation, since we're going from negative infinity to positive infinity, that would just be x is all real. Alright, and the range involves the y values, so you ask yourselves, how low does the graph go? Gets really close to 0 but does not touch it, so I put my 0 with the parenthesis. And then we ask ourselves, how high does the graph go? Which shoots off in the positive infinity direction. So that would be our interval notation. And our inequality notation, remember, involves the y value, so we put a y. And then these values here are all larger than 0. So it would be where y is greater than 0. Alright, and that's it for that problem.